This is a walkthrough for the solutions on the last homework assignment. Hopefully you were able to get the lock website to do what it was supposed to do in helping you find the statistic and the standard error and putting it all together to create the confidence interval. So I'm going to quickly show you the answers that I got for questions 1 and 2. Now your answers may differ slightly because you got a different sampling distribution from your sampling and from your own bootstrap samples. So I took, for question number 1, for the Atlanta commute time, as you see down here, I did 15,000 bootstrap samples and got a sample average of 18.46 and a standard deviation or standard error of 0.615. So as you can see on the answers right here, got 3 steps. I placed each of those important numbers in its proper position and ended up getting between 17 and 19. And the method used finds the average time for all commuters 95% of the time. For the question number 2, switching to the other website, its sister website that handles proportions, you can see my results right here between 13% and 17%. And if you had trouble working with the website, that's what this video is supposed to be doing. It's supposed to help you see how to conduct business on the internet here and working out these bootstrap intervals. So one thing I'll make note of here is that the original count, this is people who tried online dating, out of 2,001 people in our sample, 300 of them used the online dating app, which is around 15%. As it turns out, after conducting 18,000, which is just some random number that I pulled out, 18,000 bootstrap samples, I had the average of all those percentages come out to be exactly 15%. So there's some matching that goes on there in that regard. But the true number that I'm really after is the standard errors. How wide do these bootstraps stray away from the true percentage from the original sample? And so that number there is all very important and would go there in its place. All right, so let's actually move on to practicing this a couple times, and you can practice along with me with questions 2 and 3. So pause the video if you need to, or reference your worksheet. For question number 2, they want to determine a 99% bootstrap interval that will help estimate the average tip. So I'm going to do this live with you right now. So we're looking for the average tip, and this is my cookie cutter plan in terms of the information that I need. I can do the first step. Maybe it's a simple random sample. It's not very clear. I can do the third step. The method used finds the average tip for all tables that the waiter or waitress works at for 99% of the time. I'm just after this short little formula and the missing pieces that belong here. So the website will handle that. I just need to take a little trip to the internet here and find the right website. So since I'm looking for the average, I'm not going to use the proportion website. I'm going to use the one that goes along with the averages, and the data is already preloaded on here. So we're going to go to restaurant tips, and I can actually take a look at the data table. So there's a list of all the tips that were collected randomly from all the tips that the waiter or waitress worked on for maybe the month or maybe for the entire year. So this is our original sample, and from that sample we're going to get bootstrap samples. So this is the original sample here. There's 157 random tips that were taken. The average tip was $3.85. And from here, we're going to actually create bootstrap samples. We could create one of them, and I would place it right here. We could create 10 more of them. We could create an extra 100 of them, And if you just pound on this generate 1,000 samples at a time, you can actually see the sample size growing over here. And when is enough? Like, when should you actually stop? I mean, there's no golden rule here. I mean, we could be just going on for as long as we want. If you notice these numbers here, they're not changing all that much. When I add on an extra 1,000 bootstrap samples, you might hear my dog scratching in the background. I might have to get her. So, I don't know, 15,000 is enough, 16,000 is enough. I don't see much movement here on these numbers, and those are the numbers that I want to make sure I record. So the average of all the averages was $3.83 or 85 cents, which pretty much agrees with the original sample there. Really, the only number you're trying to generate from this that you didn't have currently would be the standard error, which is about 0.192. So taking those numbers over here and feeding them into my formula, the average was $3.85. The z-score for 99%, you'd have to look that up, 2.576 on that t-table. And then the standard error, which we got off the website, was 0.192. And then from there, it's just tapping this out on the calculator to get a more accurate answer, or the actual interval. So multiplying 2.576 to 0.192 will give me the margin of error, which is about 50 cents, or 49 cents. So as it turns out, the calculation would be $3.85 plus or minus, we'll call it 49 cents to be as accurate as possible. So to find each boundary, so $3.85, take away 49 cents, will give me a lower boundary of $3.36, and then adding the 49 cents to it will get me $4.34. So this waiter or waitress can claim that the average tip that they receive for each table is likely between $3.36 to $4.34. All right, for the next question number 3, is talking about a polygraph machine or a lie detector machine, and those are very interesting to me psychologically. You hear about people who can actually beat lie detectors, people who actually train for it. Sometimes they even say that people who are trained as law enforcement, such as like FBI or CIA, that they can actually be a human lie detector and tell by the way a person's posturing themselves, whether they're touching their face, whether they're blinking, whether they're looking at their hands, how their body posture is. There's a lot of ways to actually detect if someone's a liar, and some people actually claim that they can be more accurate in detecting a lie than a lie detector, the machine that people get strapped up to in the movies most often. So let's take a look. So this particular lie detector machine, we want to find out what percentage of the time does it actually miss a lie. And let's actually take a look at the data that was collected actually. So in this case, you want to actually switch websites from the one that's for averages to one that's in proportions, and that's all on the worksheet. If you press Stat key, that's another way to actually switch from one to the other, and you can find instead of having to type it in, you can actually just hit Stat key and go to single proportion, and it will switch to the one with involving proportions. So so let's actually get to the right data set. We want to go from mixed nuts, Reese's Pieces, soccer, no. Looking for the lie detector, the percentage of the time that it misses the lie. So if you look at the original data is right here. So 17 out of 48, there were 48 state lies that were made, and it missed 17 out of the 48 lies. So it missed 35% of the lies the machine did. And that is our original sample. And from that sample, we're going to generate a bootstrap sample. So in this particular bootstrap, out of the 48, 16 of them were missed. And we could generate thousands upon thousands of these. And actually take a look at, this time I'll quit around 10,000. Basically, I'm quitting when I don't see much movement in these numbers here. And it doesn't seem like adding more bootstrap samples change these numbers all that much. So these are the numbers that we're actually after. So the average came out to be 0.354, which I actually knew heading into this. The statistic will match the original sample percent. The number that I was after, though, was the standard error. So I'm going to take those numbers and apply them to the question. So question number 3, was it a simple random sample of lies that were produced? Probably not. They probably were just using the machine 48 times and counted up how many lies. They spoke 48 lies and probably just took the first 48 in a row and checked out on the machine. But so we don't know if it was a simple random sample. We know the third step, the method used finds the percentage of lies undetected. In this case, we're using a 90% confidence level, and we're going to follow the same formula. And as was mentioned in the last video, the great thing about bootstrap intervals is it doesn't matter if you're talking about averages or percentages. You can still use the same formula, the same basic formula. It doesn't involve using the t's at all. Of course, a big drawback is that you do have to have a computer to actually generate this, or as you'll see, the slowest way to do this would be to use a graphing calculator and use a random integer command. But I'll give you a little taste of that in just a minute. So let's see if I remember correctly. It was 0.354 for the statistic. If you're using 90% confidence, the z-score would be, looking it up on the table, 1.645. And the standard error came out to be around 7%. 0.068. That's right. So, all right, so just knocking those two numbers together to get the margin of error actually cleans it up just a little bit, makes it easier to discuss and communicate. So multiplying these two numbers together right here gives me about 11% for the margin of error. So we're talking about roughly 35% plus or minus 11%. So the confidence interval would be anywhere between about missing 24% of the lies up to missing as much as 0.46%. So let's taking a quick step back on this and taking a look at it. If someone was to ask you, does it miss the majority of the lies? And you would say, no, I mean, it misses the minority of the lies. So it's doing better than guessing. But really it's on the border there as maybe could actually be quite poor at actually detecting lies. But it could actually be rather good, only missing 24% of the lies that are told. And that's probably why they do ask the user many questions to get baselines in terms of the readout from the machine, and it also probably involves having someone with a knowledge of how to use the machine properly. That probably feeds into some of the success rate of this lie detector, and probably also would include having someone with, like I said, the skills or the training to be able to detect lies in person. You know, is the person sweating profusely? Is the person shifting in their seat? Right. So on to question number 4. Question number 4 might take a little bit longer to do and explain, so you might have to pause the video. I'm going to show you the results that I got for question number 4. So pause the video if you need to read this over. At least question question 4A and 4B. And once you've read that, you can unpause the video. So what do we have? We've got a toy store that has 70 different toys. I could have made it 700 toys at the store, but I just picked 70 toys. Maybe they're Lego sets, or it's just a random toy store that has 70 different toys for sale. Says take a simple random sample from these 10 prices below. So using the random integer command 1 through 70. So this is just once again reinforcing the information from the last video. So first of all, we've got a population of 70 toys, and we want to figure out a bootstrap sample eventually, but to get to the bootstrap sample, we need to get an original sample. So using random integer 1 through 70, you can do that as well. If you pause the video, do that 10 times and get a sample of 10 prices. Unpause when you're ready, and I'll just show you the results that I got. So when I used random integer 1 through 70, and remember to get to that, it's pressing math and going to the PRB menu. So I did that 10 times, and I got the following toy numbers, and that is my bootstrap sample. I'm sorry, that is my original sample. And that original sample did actually include the same toy more than once. And that could happen, and that's fine. So let's take a look at the prices for these. So toy number 56 was selected. So toy 56 cost $51, which I wrote down here. So what I'm taking is I'm taking each of the toy numbers that I found. 67 was one of the toys that was selected. It has a price of $30. So these are the prices, and these are the numbers we're going to be using to create our bootstrap sample. So that's in blue there is my original sample. Those are the original prices that I got. So how do I make a bootstrap sample from my sample? Well, how large does that sample have to be? For it to be a bootstrap sample, it has to have the same size as the original sample. So I'm going to use random integer 1 through 10. And I'm going to hit enter 10 times to create the bootstrap sample, or throw on an extra comma and 10, and it'll give me, I'm just doing this live with you right now, so it'll give me 10 random numbers from my, to choose from my price list. So math, PRB, random integer 1 through 10. And I'm picking 10 of those. So what did I end up getting? I got toy number 10, 3. I got another 3, a 2, 1, an 8, a 1, 5, a 4, and one more, toy number 10. So I'm not going back to the original population, I'm just going from this list right here. So each of those numbers represents one of these numbers in my new sample, in my original sample. So I'm just going to write down their prices here, and these are going to be the numbers that I'm going to use to complete the rest of the question. And we're almost done. So toy number 10 was worth $9. And then toy number 3 showed up twice in my bootstrap sample. So toy number 3 was $33. It's showing up twice. Toy number 2 was $30. Toy number 1 shows up a couple times in my bootstrap sample, $51. Then toy number 8 was worth $8. Toy number 1 again was $51. Toy number 4 is $50. And toy number 10, once again, was $9. So it gives me 10 prices, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops. I have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I missed toy number 5. 1, 2, 3, 4, 5. Yeah, toy number 5 was also worth $8. So I missed that. The order doesn't matter. So that's an example of my bootstrap sample. It has the same length as the original sample. And now I just have to do that 10,000 or 15,000 more times on my graphing calculator. And probably by sometime before my next birthday, maybe that would be done. Or by that time, I'd probably be going crazy. So instead of actually doing these bootstrap samples like this over and over again on the graphing calculator, we'll just go to the website to speed this process up. So if you want to do this on your own with your own list, that's fine, or you can just follow the example that I put here. So I'm writing down the numbers here from my bootstrap sample. Well, actually, I don't. I'm going to be taking the numbers from my original prices right here. So I need that list right there. 51, 30, 33, 50, 8, 40, 18, 8, 15, and 9. So remember that this website has preloaded data, but you can also edit the data yourself to put in your own information. So for this particular list of information of the toy prices, it's not found in any of these menus here. I have to actually enter it myself. So the question I have to ask myself, which often has to be asked, is what type of statistic are we dealing with? Are we dealing with a proportion, a percentage, or are we dealing with an average? And we're dealing with averages, so I'm on the wrong website. So I have to go back to the website that involves calculating a bootstrap confidence interval with averages. And go to, I'm not going to find it on my list, the toy prices. I'm going to have to enter the data myself. So as you're doing this, we haven't done this yet, you want to leave the name of the item at the very top, or change it if you want to. Toy prices is what we're looking for. You're going to cancel out or eliminate all the rest of that information there. And I'm going to type in my original sample of my toy prices. So 51, 30, 37. So you're just listing them separately. I don't think there needs to be commas in between. If this doesn't work out, it means that there should have been commas there. I wasn't looking. So let me make sure I typed in all 10 prices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We just leave everything else exactly the same. So the data has a header row, which means there's actually a name across the board there. If you click OK, hey, it worked. So this is the original sample that I took. And what we did on the graphing calculator, or what I did, is I just generated one bootstrap sample. Now, I'm not after just one sample, I'm after many, many of them. So this is the beauty of using the technique of bootstrap intervals, is I just can click generate 1,000 samples until I'm satisfied with what's happening here. I don't think there's a rule necessarily of when you stop. I'm going to basically stop when I see the standard error. Well, I guess maybe what you'd want to see is the average matching the average over here. And also maybe waiting until you see the standard error pretty much stabilize. So as it turns out right here, still not completely satisfied with it, because I want to see if I can get that. Oops, the average price is right here, 27.6. So I'm actually getting pretty close to it, and that's enough. The nice thing is, if I want another 1,000, it's like I command another 1,000 to show up. You can go as much as you want. I know some people get really ridiculous. I know there's some students in the class I know in particular that's going to want to keep on hitting it over and over and over again. And that's just kind of human nature when it comes to this, is trying to get, how far can it go before the machine actually breaks? And I haven't even tried to get over 100,000 samples, because after a breaking point is not worthwhile anymore. So if you want to try to break the internet, you can try to do that. But I think Wreck-It Ralph already did that. So so the statistic is 27.66, and then the standard error was 4.903. So those are the numbers that I need to take to finish my calculation, and we're done with this. So so I've already typed in the data into the website. I pounded that generation button to get thousands and thousands of samples. And then this is the final format to fill out. So was it a simple random sample? Perhaps it was. The method used finds the average price of toys at the store 90% of the time. My bootstrap interval is if you're completing this, make sure you tell me which interval you're using. Make sure you tell me which formula you're using, and it's just the simple bootstrap formula. And then just replace the statistic with the average, which was $27.66. The standard error is the standard deviation of that curve, which was $4.90. And then, since we're using 90% confidence here, it'll be 1.645. And then the rest is just as it was before. And might as well finish the job since I've gotten this far with it. And I'm actually kind of surprised that my dog hasn't scratched to go inside, because I'm hiding out in my patio right now. If you hear a little buzz, it's the heater. I've been kind of kicked out from the rest of the clan for today. So not that I'm sequestering myself, but basically just trying to get away from some of the noise. Everyone's busy doing their own thing. So so we end up getting the statistic, or the point estimate, is $27.66, plus or minus. When you multiply those together, it comes out to be worth about $8. If you really want to get technical, $8.06. So $27.66, take away the $8.06, brings us to $19.60 is the lower boundary for our interval. And if we add the $8.06 for mine, it came out to be $35.72. I suspect that if you did this exactly on your own, with your own initial sample, you'd be kind of in the same ballpark as me. In fact, 9 out of every 10 of you that do this will have an interval that overlaps with mine. And in general, 1 out of every 10 people that do this might end up with an interval that is completely off target with mine. And that's the whole essence of a confidence interval. So on the back there, I noticed there's some questions about asking you about bootstrap samples, and the back of that worksheet is the homework. There's 3 example questions, and the third one on global warming. I believe you can just read that right off the sheet. You wouldn't even need to use the website to be able to complete that. So yeah, I'd say practice using the website a little bit. You may want to run through this video one more time. I'd say that the worksheet that I'm giving you to do for homework is really simple, and it shouldn't take too long to do. There's 2 multiple choice questions and playing with the formula. So you should go back maybe with the video, and if you haven't done so already, conduct your own numbers through it and see if, like, let's say on this last one here, see if your answers agree with mine. I know that the next round of practice on this, you'll be using the website to enter the information and to work on the preloaded data. So good luck to you, and hopefully my screencast here will be successful, because it took me a little while to set this all up. All right, peace out.